Hey everybody, welcome to the stream. Keep bumping stuff. I'm Tony. This is my channel Gizmo, and today I just want to give a quick chat. I'm clipping, aren't I? Oh, jeez. Bump that down. Okay, that'll be better. Okay. And I just wanted to give a quick, overview of stuff I've been working on lately around Nintendo 64 and controller packs and modded for them. Full disclaimer, I'm not an electronics engineer. I had several courses in college about it, but I'm not a designer. I can't really create circuits and stuff. Definitely don't ask me to build something even simpler like a composite mod. So, but I have just enough knowledge to be dangerous, and I did stay at a Holiday Inn once. So we'll see what happens with that. Also, yeah, I know setup's not great. I got this nice little halo over my head. There's a light right there, so yeah, it's what you can do. It's what I have to deal with. Oh, jeez, backstory. You get all of my information up in front of me. I'll be honest, I wasn't going to go down this route a few months ago, but then I kept running into issues and kept researching and learning stuff and finally came up with some information that might be useful to people. I don't know. We'll see. So what I have here is, this is my original Nintendo 64 controller pack. I bought this probably in 1998, and it doesn't work. I plugged it in to my Nintendo 64 with, I tried like Perfect Dark, Turok, Top Gear Rally, a couple different games that support memory cards, and it couldn't be read. That's not that big of a deal, because I thought, it's probably just the battery's dead. This thing's is over 20 years old. It's probably time for a new battery in here, because this thing uses static RAM, which has to have a battery to keep its data. But that didn't work either. And I'll show you right here. So this is the inside. We've got memory module. There's a little IC. I'm going to talk about this in a moment. And on the back side is a battery. And this is just a CR2032 coin cell non-rechargeable battery that just has solder tabs on it. You can get these really cheap off Amazon and eBay. I have a 10-pack. I spent like $3 on it. And yeah, despite replacing the battery, this thing still couldn't be read. So I was like, well, I guess it's time to go try something else. And that's when I fell down a big rabbit hole. Long story short, let me pull it up. I remember going to Retro RGB, and there was a post from Smoke Monster, I believe. Let me put this up. Yeah. So a post from Smoke Monster talking about, hey, somebody's building PCBs for FRAM and selling them. It's like, that's pretty cool. And you start looking at it, you're like, that's not that complicated of a circuit. I mean, could this be retrofitted into existing controller packs? Because right now the guy who built these, he doesn't have any for sale on eBay. He doesn't have a store anymore, I guess. So there's nothing really, you can't really go buy these. And so, I started doing some searching around the internet, and the first useful thing I landed on was this post from elephantfleet.pw. And it talks exactly about, doing an FRAM mod onto an existing controller pack. Pull the battery out, desolder the module, solder in the new module, and hey, look, boom. You had Perfect Dark reading and writing to the module with no problems. He did go on to talk about, doing a mod to it, and I'm going to talk about that in a moment because things get a little interesting. But he wasn't the only source. He originally got the idea from, I think, this blog post here at QWERTYMOTO.com from back in 2012. This guy, he went back and learned the pinout of the controller pack so he could build an FRAM module. And a lot of good information here, especially the pinout, because I think probably at the time there wasn't a good information about what the pinouts were on the controller pack. but that's been duplicated in a few other places. If you, in fact, back in 2014, this is his website, not his blog, although they're at the same domain. He actually, the guy at Quordimoto actually has an Eagle file. So Ben here actually has an Eagle file you can download and basically get your own PCB printed. It's pretty simple design. It replicates how FRAM Mod, the controller pack's wired up with, you know, filtering capacitor and a few resistors and other things to just make sure everything works correctly. Also found, Quordimoto, he also linked to an old post from the Ben Heck forums, which I'm surprised that's still around, from 2010, and where somebody actually took an FRAM mod that isn't even the same physical package and manually wired it onto a PCB. And I thought that's kind of insane. Look at that. Interesting stuff. So, and also another blog post here from, I think this is from, might be a little bit older than Elephant Fleas, but same type of thing. You know, going through, removing the battery, you know, using hot air station to remove the chip, and then putting on a new one, and boom, call it good, go. So lots of good information out there. There's, I think, like 2 or 3 YouTube videos. And yeah, but I started trying to, so I did one myself, and it went pretty well. You know, there's people, you know, there was a note here on Elephant Flea, if you scroll down here to the bottom, talking about, hey, you know, there can be a bit unstable, and I experienced that myself. Like the first time I plugged it in, like Turok's like, I can't read this. I unplugged it a few times, plug it back in, and then Turok's like, oh yeah, I can, this is no problem. But then I got into the game and tried to save, and it errored out, and then unplugged, plugged it back in, and it started working again. So yeah, it can be a bit finicky. And you know, Elephant Fleet here says, you know, the solution might be to, you know, attach pin 21 or it's gonna be pin 28 of the FRAM module to the battery positive terminal, and I don't think that's quite right. And that's where I really went down a rabbit hole, because I think there was a little bit of misinformation on that, based on, you know, trying to remember stuff from memory, and it just got passed along. And yeah, I think that this could, it's not that this is bad, it's just that I don't think it's the best solution. So if you read here, he's talked about, you know, it could be a bit unstable. It could be due to the N64 trying to think the controller battery's flat, and one of the solutions stuck on 42's blog was where the positive pad was connected to connect the positive pad from the to 3.3, and that's actually correct. So if I go back over here to Quordimoto, and you gotta remember, this post was written back in 2012, and then 5 years later somebody came in here and asked, like, hey, you know, if I'm swapping out the RAM chip, do I need to do anything extra, whatever? And the guy behind Quordimoto, he's like, yeah, you just need to make sure that, you know, you're connecting, you know, 3.3 volts VDD, VCC, whatever you want to call it, to you need to connect it to pin 28, and you know, you need to tap it. You need to tap into that. And he said, I think you can get it from the positive battery terminal. Let's see what he said, including pins 4 on the card edge, and or the vias attached to those pins, or pin 28 of the chip. It's just use a continuity tester. But you know, it's been a while since I've done this, so I can't really confirm that, but it should work. And he was mostly right. Like, if you look at his EagleCAD, it's totally true. You can pull VCC from pin 28, but I don't think we need to do that at all. And I started getting into some really deep stuff. So if I pull up, let's see what my notes say. So let me pull up this guy. Where are we going? Where are we going? Bring that back down. So put the case aside. So if I bring this into the camera, I gotta change stuff, and focus. Yeah. So I mentioned that there's two main chips on this. This is just a capacitor for filtering the power as it comes in. But this is SRAM. This is the actual memory module. And then there's this little guy over here. Now, if I flip this over, it's got some lettering on it. You know, 9803F 7518. There's some others, like there's another common IC is 7416. Looks like it has a little Texas Instrument icon on it. I can't find any information on these little things online. I can't really find a data sheet. You can kind of find sellers on Alibaba that has 7416s for sale, or AliExpress, but there's no associated data sheet. But I think I managed to figure out what it is, and it's kind of obvious and kind of simple at the same time. It's the power control circuit for the SRAM, and what it's designed to do is take the power from the battery or from the card edge connector and switch between the two depending on which one has power. So if there's power coming from the card edge connector, then it's going to send power through that. If there's not, then it's going to pull power from the battery. And then also there's the chip enable pin on the SRAM goes through this little IC, and it's supposed to be held high, so at voltage, if there's no power coming from the edge. And when this is held, when the chip enable is held high, the SRAM goes into a standby mode. Let me show some information that I'd found on that. Pull the browser back up. Go back over to my browser. So yeah, I was just trying to figure out, what does this little chip do? And lo and behold, there actually was some documentation out there. It's not directly related to like how the controller pack is designed, but you know, Cypress they actually have a document for designing recommendations for battery-backed SRAMs using Cypress SRAMs, which this kind of applies to most other SRAM modules. And it really lines up with this guy. So you're supposed to have regular power supply, which, you know, that's coming from the controller. You have a battery, and then you have the supervisor chip, and it controls what power goes to the SRAM. Dig in deeper, and they talk about, you know, recommendations. They have, like, this is the old way where you just use some diodes to make sure the current didn't go backwards through circuits. Like, you didn't want power going into the battery because trying to charge a rechargeable battery is bad. So you use this diode to keep it from going backwards. But this is one of the recommended ways that Cypress says is, you know, you got your microprocessor, which in our case would be in the Nintendo 64 memory controller that's on that. You have the SRAM down here, and then you have a microprocessor with, you know, supervisory chip, and that's that little 7416. So input comes in power from the battery, power from another power source. You have CE coming in from the microprocessor, or in our case the edge connector, and then you have CE and power going out to the SRAM. And if you look at the wiring and you do a trace with it with a multimeter, you end up seeing something like this. So here is our power from the hard edge, and this is not really good. This isn't really how things are wired. This is just for display purposes only. Is it goes up through here, and it goes into this pin 8 on the IC. And then same thing for the battery. So battery comes over here, it goes into pin 1. And then power comes out of pin 2 and goes over to pin 28 of the SRAM. And then also chip enable goes up here, it's in here, and then goes out to there. So the thing you run into is with the idea from Elephant Flea is take pin 28 from here and connect it to the battery. Why do I think that's not the best solution? Basically, you're just taking the output of this power control chip and feeding it back into the input. So you're basically taking pin 2 here, which goes over to here, and then you're connecting it up here to the pad, and then that goes over through this little resistor back into the IC. And that's not really, I don't think that's the optimal way that should happen. Because without a data sheet, we don't know what this little chip does when there's no power constantly being fed to it from the battery. Is there a delay on boot up when power comes in from pin 8? You know, is something floating, you know, as that's happening? There's a lot of unknowns. I don't know what's happening with the chip enable line when things are when stuff is happening. So I do think that Quordimoto is correct, is you need to get power from here, but we can get it from other places. So like pin 8 here, that's directly connected over here, so we can actually just take, you know, this power and then just jumper it over here. That's kind of one of the ideas I've had, is, you know, let's just take power from here and we'll just run it straight over to the power input of the IC. And I've actually tested that. Let me pull up, get back over here to the camera. FRAM. Or take pin 20, or take, actually what I tested is taking power from pin 8 and just driving it back up to here. Because if you do that, now power is coming in on both inputs on the IC at the same time. And I think that's at least better than trying to take the power output of the IC and then feeding it back into itself, because there's going to be a delay. Even if it's nanoseconds, there's going to be a small delay in how fast the transistors and whatever in this circuit can switch and turn on. But I think there's actually a better solution than that. It's a bit more involved, but if you're replacing this, then it's probably not that much more difficult. And that's to remove the 7416 IC altogether. Again, I don't have a datasheet on it. I can't find a datasheet on it. So what's actually happening with it? Couldn't tell you. And since that's not needed for FRAM, and that's the only thing it's being used for, it would be just as easy to remove it. So my idea would be to take off the IC, and then you bridge pin 1 to either pin 2 over here, or you bridge it over to pin 28, and then you have to bridge the channel, the chip enable lines, like just right across pin 4 to pin 5, or just take pad 5 and then run it over to pin 22, which is that little tiny dot right there. That's pin 22. That's chip enable. Pull up my notes. Not placing the flames. Yeah, I put it in my notes. Not placing the flame. I don't blame anybody for having this for this. You know, like I said, it was, the writer at Quordimoto, Ben. He was having to remember something from 5 years after creating that original blog post, and 3 years after he released the PCB. I'd probably get that wrong too, unless I was actually sitting down looking at it. And yeah, it's really easy. It's really easy to just pull power from pin 28 there and run it up here. It's a really easy path to run compared to running it, from over here or coming all the way over here to one of these. There's some vias like right there, and I think you can actually pull power from like these two vias as well. Right there where my fingernail is, but I'd rather not. So that's part one of what I discovered on all of this is I think there's a better way of doing power for the FRAM, and that's basically removing this IC and then making the bridges that we need. Then while I was reading data sheets, I found something else interesting. And I think it's important to know for all SRAM to FRAM mods, because I think it affects all of them depending on how things are designed, and that's timings. So excuse me, people who've written blog posts like, hey, yeah, SRAM, it's a drop-in replacement for SRAM. It's not a 100% drop-in replacement. Pull up the browser again. So if I go over here to this document, so this is the datasheet for an FM18W08 FRAM module. This is what you'll see commonly used for installing into SRAM, into controller packs. It's also what gets used a lot for the FRAM mod for the Sega Saturn. And there's a really there's an important disclaimer down here, and it says FRAM design considerations, and it's pretty clear. When designing FRAM for the first time, users of SRAM will recognize a few minor differences. The first bit-wide FRAM memory latch address on the filling edge of the chip enable, that's how SRAM works. But it has to be done every time the address changes. So since every access latch to the memory address is on the falling edge of the CE, users cannot ground CE chip enable as they might with SRAM. Users who are modifying existing designs, that's what we're doing here, to use FRAM should examine the memory controller for timings compatibility and of address and control pins. Each memory access must be qualified with a low transition of chip enable. In any case, this is the only change required. And here is an example of the differences. And if you go looking at spec sheets for Ramtron and Cypress and many others who you can actually find SRAM chips for, they all have the same disclaimer. In fact, it's actually copy paste, so I think Cypress actually wrote it. But this is what you would normally see for SRAM, is what I'm assuming. Oops, I have highlighter on. Anyway, and so basically what happens is when you go to read and write data from the SRAM, chip enable goes low, and it stays low the entire time you're accessing all the different addresses available. Whereas with FRAM, every time you need to change the address, you're supposed to strobe the chip enable line back high and then low again. And it's my assumption, and I could be completely wrong with this. I have again, I'm not an electronics engineer, that this might be the source of some instability when it comes to accessing and reading and writing to controller packs. Like with Turok, for example, it may not work the first time, but you unplug it, plug it back in, and then the next time you might get lucky and it works. And I don't know if anybody has talked about this in the retro gaming community, especially with the Sega Saturn mods or the controller packs or any of the other game cartridges that are out there in the world that have SRAM backups, and people have tried to do FRAM mods to them. I'm not saying we shouldn't do it. I'm just saying we should probably have disclaimer saying, hey, this may not work. Obviously, it does work. So these chips are these chips appear to be a little more tolerant than the writing says in the datasheet. But it's just something that I have not seen anybody discuss before. Especially I was looking through on Retro RGB, and there's the post from Rene at DB himself years ago when he did the SRAM install on his Sega Saturn, and then Bob did one a few years later, talked about changing how some pins are connected. But they're both using FRAM, and if they are, then this same disclaimer should apply to the Sega Saturn too, which it's kind of crazy that it does work. So that's the two big things I've learned about this, is the power and the differences between FRAM and SRAM timings. Do I think this could damage our consoles by doing this? I honestly don't think so. I think the biggest issue we'd have is data corruption on reads and writes, but that's going to just cause that's not going to cause damage, physical damage to our hardware. These chips are still rated for 3.3 volts. That's what they're receiving from the controller or from the console. I think it's just, you know, if somebody's having, you know, issues, there might not be a full permanent solution unless somebody was to go modify how we read and write to these chips. You know, on the Nintendo 64, it might be something as simple as modifying or patching a game cartridge. You know how the game reads and writes data. For the Saturn and like it might actually require a mod to the firmware, which I don't even know if it's possible these days. But yeah, that's what I got. Let's see. Pull that back down. So, as I showed over here, I did, you know, the simple power mod on this on this PCB where I just connected, you know, I pulled power from this pin, which is pulling it from over here, and I just sat it down on the pad. So again, power's going into both inputs on this IC before it heads over to the FRAM. So now what I want to do is I actually want to try my idea of removing the IC altogether and replacing it with some jumpers. So let's see what we can pull off here. Disclaimer: I don't have a hot air station. I know Bob from Retro RGB says get the right tools for the job. I don't have the right tools for the job, so I'm going to do it the hard way. And that's totally on me. I totally understand where he's coming from, and you know, there's not really a whole lot I can do. So what I'm going to do is I'm going to remove both the SRAM module from this PCB and the power IC. I'm using nothing but a soldering iron, some solder braid, some flux, and a tiny screwdriver. Let's see how this goes. I'm going to need to brighten this up a little bit. There we go. Now we can see. Yeah, I'm using webcam, so I don't have the greatest video quality, but you know, like I said, use what you got. I'm all about trying to make things work and not spending a whole lot of money. I'll spend a lot of time, but not a lot of money. I'm just going to get a little bit of solder paste, solder flux. This is my crappy Radio Shack solder flux from I bought like back in 2010. I really need to get rid of this stuff and get some good stuff, because it is sticky when it dries. It is just a pain in the butt. And now I'm going to just take a little bit of solder and get these pads. As I drag everything across the table with the cord of my soldering iron. Move all that out of the way. And here we go. I have not mastered the art of dragging, and it probably doesn't help that I've got this at an angle. So, where's solder braid? See if I can do this. Let's see if I can do this without burning my fingers off. That was actually a pretty good pull. Ow, I burnt my finger. I'll be honest, I am not the best at soldering. I get impatient, especially when things don't move like they're supposed to. You know, you'll sit there and watch Voltar and he makes it super easy, makes it look super easy. And then I'm here, you know, like spending like 5 minutes trying to get this stupid solder hot enough to flow. I should probably remove the battery too, shouldn't I? Yeah, I should probably remove the battery. I've already removed this battery once, so it's got fairly new solder on it. Let's see if we can get this thing off. without pulling surface mount components off it with it. Okay. Ah! Out. Without even having to pull on it. Awesome. That's cool. Alright. Let's see if we can get the bottom desoldered now. Probably need to trim off some more of that. Let's see what happens. I didn't put any solder on there, but there's some flux. Okay. That should be good enough for phase 1. And now we need to go on to phase 2. Tiny little screwdriver. I have my cable tied up in my cutters. So I did this once, and all I'm going to do is I'm just going to heat up the pin, and I'm going to feel it gets hot, and I'm just going to lift it off the pad and move down. Probably move up the side of the package, and then I'll do the same thing on the other side. There we go. Got it. There is one removed SRAM module. Okay, now time to remove the IC. I do need to be careful on the bottom because there's a capacitor, or there's a filter. I guess it's a filtering capacitor or something. It's a tin. I have no idea what the size of it is, but it is surface mount. It's that little guy there. That one's not important, but that one I actually want to reuse because it runs in line with the power coming from the edge of the edge connector. That looks pretty good, and I have all the pads still. So our next step is to take an FRAM mod and install it where the SRAM used to be. Now, this can be a tiny bit tricky because I feel like these are a tiny bit more narrow than the SRAM, and I could be totally wrong about that. But when you look at lining this guy up on the pad, no, it is more narrow. Okay, I'm not crazy. So you can see there that it's just a few millimeters more narrow, and that makes it really fun on trying to get this guy to sit on the pads. So I'm actually going to have to set this flat, way it doesn't move around. It's going to move around, but I gotta set it down flat so I can actually get it lined up the way I want. Because we're talking, there's not a lot of overlap on the pins, of the pad. Now that I got it where I want. Take some solder, and I'm going to try and get some corners down. There, Easy as that. Okay, the last thing I need to do is I need to get some jumpers, and I need to go from pin 8, where the IC used to be, pin 2, or I can just run over to pin 28, and then I need to run pin 5, which was chip enable coming in from the edge connector, over to pin 22, which again is that one tiny little dot there. But I flipped this upside down so we can see it better. This is why I'm not doing a DC digital mod or next station or an N64 digital or any of those that requires really fine soldering. This is, you know, this pitch is hard enough for me. I can't imagine doing even tighter pitch stuff. There we go. Again, it's not pretty. I never claimed to be good at soldering. That should be it. Let's give it a test and make sure there's no shorts. And then do I have power? Yep. Enable. I do. Good. So, in theory, if I put this in, and I'm going to clean this up after this is all done. Go ahead in the other one. So I'm gonna tuck your rally. Now, all right, let's get up Nintendo 64. I'm going to press and hold start. I'm going to turn it on. Okay. I expected that because it's not formatted. Attempt repair. Oh. Yeah. Okay, well. That was fun for a whole lot of nothing. Let's play around with it, see what I can figure out, but in theory all of that should work. Okay, well, that's all I got for today, guys. I gotta go. It's been fun streaming for the first time in forever. I had one viewer that wasn't me, I think. Thanks for watching. And as I always like to say, until next time, have fun. Alright, hey everybody, I am back. Took a break, had some dinner, thought about this, and looked at some more things to figure out if I can solve why removing the power IC from Controller Pak caused it not to work as I expected. So, and I think I figured out the problem. And it all goes back to the chip enable line. So before I stopped, what I had done is I'd wired basically the chip enable line, which is from the edge connector, which goes up here to pad 5 on the IC. That pad right there. I just wired it straight into the chip enable pin on the FRAM, and that won't work. Well, it didn't work as I shown at the end of the stream. So the solution is actually, again, it's in the data sheets. So if I go over to browser, right after my notes about the whole signaling thing, there's this whole note about chip enable line, what it should be doing during power up, power down, and the basics of it is you need a pull-up resistor on the chip enable line to power. Now this can be any large resistor, like a 10K. That should be more than enough. And that we need to we basically need to do that. I actually tested this off camera and it worked. So let's go ahead and look at it. Oh, and really the thing that led me to this was I ended up having to look at Korimoto's the Eagle files from Korimoto.com that he posted. I'll show that again. So here's the website, non-volatile N64 controller pack. He has the edge connector pin out, and then down here he has the he has a CAD file. So, and I can pull that up and show you what that looks like. Hopefully without OBS crashing, as it just crashed on me a moment ago. Not that one. There it is. And this little piece of the schematic right here is the important part. So here's the CE line, and then there's a 10K ohm resistor to power. If I go back here to board design, that's exactly what it does here. So here's chip enable. He runs it up here, around, and all the way over to pin 20, not pin 22, like I was saying earlier. And then here's the 10K R1 resistor that goes down to VCC, which is running through there to a VIA that runs over to here. So what I'm going to do is I'm going to take that information that I have learned, and I'm going to apply it to this board. So I don't have any surface mount components. There we go. Okay. Right. So I don't have any surface mount components, so I'm going to have to do this a little bit differently. What I do have is just some regular full-size 10K resistors, and I'm just going to use some vias to connect it together. So there is a via right here next to R3 that is running over to the output chip enable of the power IC, and then I'm going to connect it over to one of these three vias on this side, which is coming in from VC. And I'm going to do it on the back of the board so things are it's more cleanly ran. There's plenty of space on the back of the board because remember, there used to be a big battery right here. So there's a good gap. And I'm just going to pop that in there, run it flat. And we'll just solder that in and make it pretty. One more thing I want to do is I need to reconnect chip enable coming from the edge over to here. But instead of going that direction, I'm going to run up here. I'm going to tie into this leg I just ran. Honestly, I probably could have just bent that over and wired it, but I didn't. I don't trust myself with the legs. And just for testing, before I cut these off, pin them down. Drop this in the case. I'm going to put the back on it yet. Pop it in. So again, see if I can get that in there. Still the same cartridge, so let's see. Let me pull up. Alright, so yeah, I'm holding start, powering on the console. Perfect. I'd already formatted it and everything, so as you can see, it perfect dark for some reason. As soon as you put a controller pack in, it automatically creates a save file. Kind of annoying, I think. That was World Driver Championship, by the way. It was made by the same developer. It was made by Boss Games, the same company who made Top Gear Rally. All right, I'm gonna try Perfect Dark. Ta-da! Beautiful. Okay, so I'm going to bring that back down. And last thing to do is just cut off these little legs. Yeah, not pretty. I gotta find my flush cutters, but you know, you get the idea. Should now be able to pop this in, put the back on. And there, one fully modded Nintendo 64 controller pack with an FRAM. And it only took me months to figure out that information. Oh, yeah. So there's the resistor. Again, it's just going from power over to that via right next to R3. And then we have, we have power coming in. We have power coming in over to pin 28 on FRAM. And then we have a jumper going from chip enable, which is coming in from down here, over to our resistor, which is already connected to pin 20, pin 22 of the FRAM. So that's all I got. If you watched this entire thing, thank you. I really appreciate everybody coming by and stopping in and saying hi. And as always, have fun.